Okay, so today I'm going to be talking about the asset database system that I've added to the game, and also pixel per unit, which is what you use to determine how big your sprite is relative to your unit space, among other small optimizations and things that I want to do next. So in order to properly implement pixel per unit, and moving forward I'm just going to call it PPU, I needed to create a asset database which allows me to essentially associate a pixel per unit value with a texture. But also we want to make sure that we're not hard coding file paths to our entity and to our world. So before, what we were doing is underneath the sprite component, we would essentially say file path, and then we would provide some sprite to this file path. And the issue with this is if we move the basic door PNG anywhere else, this world file will not load correctly, or actually that's like the worst case. What would probably happen is the entity would be missing its sprite. And of course we can throw an error to let us know that, hey, this door doesn't have a sprite. So that's a problem. And obviously if you know about your relative file paths, you can go in here and fix it, but that's tedious. And then of course there might be some things you can do on the editor side, where if a designer or an artist changes this path, we could update the world file, but then that's also costly. So what we're going to do instead is we're going to create an asset ID for every sprite that we import into our game. And then if we want to move that asset around, like the sprite, to a different location, then we just change the file path behind the index or behind the ID. And the way that works is we have a database file, essentially, I call it .index, where we'll just essentially write out all of the sprites to this file that exist. And right now we only have two that are registered. So we have the basic door and the demon swords ethereal, which is what I'm using right now in the game. We can obviously add other asset types to this. I made sure to support that, so you can see underneath there you can specify the type, and it's specified as sprite. And the big thing here is you can actually set the pixel per unit value, which for the basic door is set to 500. I don't know if that's accurate. I just kept it that way so that it was to scale. But when I export these out of Unity into this engine, I can just set this value from Unity and it should work the same, because everything that I've been doing has been to scale with our project in Unity. And of course the Demon Swords Ethereal uses a different pixel per unit. And arguably we should probably have one pixel per unit for everything, so resolution sizes are consistent, and we could enforce that. But there are some things that we do scale, so having it here is just flexible. Maybe we'll migrate stuff over and make a list of things that we need to update on the art side to fit a consistent resolution, but so far everything is working fine as is, so I'm just carrying over what we had in Unity. And Unity does something very similar, except they use meta files. So if you open up the meta file for a sprite, you'll find the pixel per unit value somewhere in there. Or the meta file will have an ID that points to some other system that stores it, but it should be in the meta file. In fact, I think we could confirm that real quick. So let's see, let's go to levels, or no, level objects, if I have it. And there should be a door Z face, basic, And so if I go to like the frame here, we have this texture importer information where it stores all the information that the designer or artist can change. And one of these should be pixel per unit. Now they do a lot of compression for you, a lot of other tweaks. Let me do a search here. Pixels to unit, there it is. So you can see this is set to 100. So I'd probably use 100 as well. That makes it very big. We might be scaling things down. So pixel per unit is just another way of scaling the graphic. We just kind of hide it from the designer. So when you're messing with the scale tool, you're just changing like the XYZ scale, and then pixel per unit is there to scale it as well, but it's more so to keep it relative to your unit space, which is very useful. And that's basically what we're doing, right? We're doing the same thing, except we're not splitting it out into multiple files. We could. We just have to make some kind of like file watcher system that knows how to like associate the meta file with the asset. And usually the meta file and the asset have the same name, so that's how you would do it. But I like this approach. Our game's not going to be super massive, so we should be able to maintain our assets here. And if it ever gets to a point where this is not maintainable, we can easily refactor it to be broken up into multiple files. But also, this is going to only be used during edit mode. When you go to compile the game out and ship it, everything's going to be packed into binary files that are optimized for level loading and all of that. So this kind of goes away when you export your game, or I should say compile the game and produce the binaries to upload to like Steam or Xbox. Yeah, so that's what I worked on today. I made this asset system. So instead of using the file paths, they're now referenced here. So if I want to change, where this is located, I can, or if I want to change what it points to, I can. That's very nice and efficient. And then this ID is basically like always going to stay the same. This should never change, and if it does, we're purposely doing that. And we use it inside of the world file to determine what asset we load. So this right here is actually the ethereal sword. And if you go to the index, you'll see that its ID is 1, and it will load the sprite. And this is using a different pixel per unit. And if you look at the world file, the scale is 1 by 1. And so before I had to scale these values specifically, I think I had to do something weird where it was like 1 and then 3.8 something something. Well, that calculation happens for me based on the pixel per unit value stored in the asset. And when we load the asset and then the texture, we calculate the ratios that we need to use. And so now the sword actually renders at the correct aspect ratio when I set it to 1 by 1, whereas before it was crammed into this quad, because a quad is just a unit square. So now if I want to, I can change this to 2 by 2, and it will change it relative to the size of the texture. So there's no more weird stretching, as you would expect, right? And you can see here when we go to render the sprite, or actually right here you'll see this is where we're calculating it. So this is where we actually load it in from the file. So we get the texture path by using the asset system. So you can see here we have an asset ID. We parse it out of the file, and then we pass it into our get asset path. And Unity actually has something very similar to this. Like if you were to, let me pull it up. Funny enough, Unity has its own get asset path, and you actually give it a instance ID. Now we're not using instances or we're not using instance IDs to do that. We're just straight up using the asset ID that we pull from the file, which is all we really need. And then once we have that, this right here, this code's a bit verbose. I might simplify this down, but basically you can load the texture to the cache. So there's a cache that we have for caching textures to make it fast, because you don't want to keep loading the same texture repeatedly. Like we have 60 doors and they all share the same texture. So we don't load the texture 60 times. We load the texture once, we cache it, and we return a texture ID. And then you can use that texture ID to grab the entry, and then from the entry you can grab the texture view, which is what we use for rendering. We have to pass that over to the sprite. And then of course we grab the PPU from the sprite asset. And here we can calculate the scale values. So behind the scenes, PPU scale is just another vector 2 that then gets factored into the rendering matrix. So you can see right here, before we send this off to DirectX to be rendered, we specify how big it should be, and it's just multiplication. It's just scale x times PPU x, and same for the y. And of course, if I get rid of these two values without deleting commas, you'll see that this will squish it down to a 2x2 quad in the corner of the screen. So this is what happens when you don't factor in pixel per unit. Then from there, as the designer or the artist, I have to actually calculate what it should be so that it stretches it correctly, right? We don't want that. We want to be able to say, no, pixel per unit makes sense to me, so I'll just use that. And then I can scale this freely however I like. And this is important for us because we use this quite a bit in Cultist Astronaut in our Unity project, and we want to be able to mass export those from Unity to this engine. And I do have a script on the Unity side that will export objects from our scene to the world format. And I'm going to expand it to support the asset database so we can export all of the sprites we've created and configured in the Unity editor. So yeah, that was the pixel per unit implementation. We can look a little bit at how the asset database works. So I made a note up here that this will be editor mode only. In order to do that, we have to create the asset packing system, which we don't have. So right now, if we want to run the game, we have to have the asset database behind it. And you can see here we have an asset type where you can specify what the asset type is. I don't think we're going to have hundreds of these. It should be just like very basic types like sprite, entity reference, etc. And then you can see here we have the structure that defines what a sprite asset contains. So right now we only have pixel per unit, but as we were looking at like what Unity had, which I closed, we could definitely add more settings here, like different compression settings, etc. if we want to get into that. I don't think it's necessary, but the option's there when we want to extend this. And then the asset structure just has an ID, has the type. We use this if we need to resolve what it is, which basically lets us figure out what variable we should use inside of this union. And then we have a file path that points to the asset on disk, so we can load it. The asset itself doesn't actually have the binary data for the PNG or for whatever asset we're loading. We load it when we need it, which is what they call lazy loading. And we can load a bunch of assets before we load a world, and we can optimize things that way. But when you load the game, we do load in the asset database, which just maps an ID to a file path. But that's it. We don't load in the actual textures and all the information. So yeah, like in the future, we'll also have like, audio. We're not going to load all of the audio into the memory. We're only going to load what we need. And we're going to use the asset database to figure out where that resource is located. And then a union is a concept that was unfamiliar to me until recently. but it's a really cool construct. It basically allows me to insert memory into this structure with a specific type. And then I can add other structs, like, I'm probably not explaining this in the best way, but I'm going to try my best. I can add like an audio asset, and then I can say an asset can also be an audio asset. But only one of these can be active, right? So if I create an asset instance and I make it a sprite and I change this value, then this is the active memory. But if I change audio, this is the active memory. So they both occupy the same memory space, but I can call them in the code using .sprite or .audio if the type matches. So it's a type of polymorphism. So instead of using inheritance, you can use a union to basically say, hey, figure out the largest memory footprint you need in order to store this, and then treat it like a sprite asset or treat it like an audio asset. There's probably better explanations online, but that's my best attempt based on what I've learned recently. And it really makes this much easier to process, because what we want to do is we want to be able to declare a big fat array of assets and then iterate over those. And in order to declare a large array that's contiguous, I needed to be able to use this union to put that memory in place. Whereas if I made it, if I used inheritance, I would have to allocate a pointer. I'd have to do something like this, where it's like, either I do this where I have like data, or I have to use inheritance like this. And I'm using this on the wrong thing, but basically I inherit asset, right? But what this does here is this forces me to make this array over here. It forces me to make it an array of pointers, and at that point I have to create it on the heap. I have to new it up somewhere, and that's annoying, and it doesn't make it contiguous because those assets are spread apart. And there's ways of doing that where like you allocate up arrays and all that jazz behind the scenes that you can pass into this, but this is simpler, much easier to understand, and it's fast. That's important because we want to be able to iterate this thing very quickly. And yeah, when I load in the assets, here's the parsing code for that. If it's a sprite, we set the type, we set the PPU, and that's all we have for now. There's a couple things I haven't implemented yet, like saving and registering. Registering is what you'll use in the editor when you import a new sprite or a new audio clip. And that basically just registers it to the array, and then saving it will just dump that out to the file. And maybe we'll optimize that. I need to learn a little bit more about exporting to a massive file. That's where metadata files can be helpful, where you break it up into multiple metadata files, because then you don't have to dump out a whole text file when you save. You just, update the meta file. But we'll see. We're going to try this for a bit. Again, it's all something we can easily refactor. There's not a whole lot here. It's not a super complex system, so it should be fairly easy to refactor. And yeah, there's our get asset path. So some people may look at this and say, why didn't you use like a hash table or like a dictionary-like structure? And it's because we don't have that many assets. And also, this is a very optimized array that we can blaze through. And we're going to be using it for the editor. So until it becomes a problem, I'm just going to use a for loop that checks the ID and returns it, because that's fast right now. And if it ever becomes a problem, it's not rocket science to swap this out with a different data structure. So I'm not going to pre-optimize it. I'm just going to get it working. And this is actually probably more optimal because we're not dealing with thousands and thousands of sprites. We're dealing with, maybe hundreds. And that's not rocket science for the computer to process. So no reason to do anything overkill. If this was like a general purpose engine that people were using for all variety of games and there was like thousands and thousands of assets, then maybe you would spend a little bit more time optimizing this and choosing a different approach for some of these things I've done. yeah, so that's what I was able to achieve today. Tomorrow I'm going to get back into some gameplay stuff. So I got the sword loaded in. We want this sword to fly around on the screen and attack the player. So I'm going to build a collision function that basically damages the player. I'm going to create a damage component as well as a health component. And then, we'll wire those together and then create a movement function so the sword can fly around and chase the player. And then we may end up doing some aiming and rotation. Now that I have all this stuff laid down, we can easily get that knocked out. But yeah, that is all for today.